for today. We're going to go through the motoring on virtual lab. I know some students have had questions on some of the parts. Really, if you're following along and reading through every lesson and you're reading the directions and those types of things, it should be very, very simple. So I'm going to take you through and kind of show you a couple things and make sure that you are squared away to get that done. All right, so just remember our communication guidelines. So as long as we are in a live session together, please don't share any personal information, but feel free to use the chat box. All right, so our objective today is we definitely want to interact with each other. We are getting into the very last time, so before you guys move on, most of you move on to high school. I don't think, I've had very few 7th graders taking physical science this year, but some. So most of you guys will be jumping on over to high school, so that is a very fun time. All right, and then we are going to interact with the curriculum, just taking a look at this teacher-graded assignment, making sure that we have everything in there that we need. All right, so part 1 starts with the electromagnet. So I'm going to share my screen with you and just kind of make sure you're able to see how we are getting to this point. All right, so this is the view of your science homepage, and I know many of you just work from the daily plan, and so sometimes you are not seeing or able to go back. You don't really know where to go back to get into the lessons to look at things again in case you need it. So if you log into your science homepage and you go to content, and it takes so long when I screen share for it to actually load up. So you scroll down, you can see all the work in Unit 5, and we want to start here with this Build an Electromagnet Lab. Okay, so this part is not submitted yet, but it is the exact same assignment page. So when you go through these steps to build your electromagnet, or maybe you weren't able to do that, so you watched this video on how to build an electromagnet. Okay, hopefully you read through the topic review and the steps on how to build it, even if you were not able to, so that when you got down to this page, okay, you were still able to open it and print out the assignment document. Okay, and if I click on that now, it pulls up a Word document, but it won't show, it'll be a gray screen. So we won't do that. But it even talks about here that you will turn in your assignment in the next lesson after you complete the second part about investigating the motor. So for those of you that have had confusion on what to do with this, it does tell you right here. Because if you notice, the first 5 questions are about the electromagnet, and then the last 3 questions are about building the motor. So you have to have done both activities in order to be able to answer the questions. Okay? All right, so if we jump back out of the electromagnet lesson, okay, it takes us back over to the screen, and we're able to see all of the lessons in Unit 5 again. And now we can go back down and look at the motoring on assignment, because there is a drop box here. So now we know, okay, super, I can turn this in. It is the same assignment page that we saw earlier. But if you click on it here, and, oh, it's the student view, it's not going to show. So this assignment page is that Word document that we'll be working with today. Okay, so there's only 3 questions about motors, 5 questions about electromagnets. All right, so we're going to jump in and look at those things together so that we can answer all of those questions together. All right, so let me get our first video. If you were not able to build the electromagnet, we're going to take a look at a quick video. This is the same one shared in the lesson, and it just shows you really quickly about the parts and everything that they do. So let me get that link for you. All right, here we go.
This video will show you how to build an electromagnet. For a fun science project, you can build multiple magnets with different size wire coils and measure how.
All right, so you can see it was a very basic, simple experiment, and you should have had those pieces. I think the battery and the connectors, the wire connectors, are all in your science kit. Paper clips obviously would not be, and I don't think there's a wire stripper in there, but again, you can see that he just used sandpaper on some fine wire. So, and then the wires that you guys have exposed ends where they hook to the battery, so I don't think it's an issue of needing to actually even strip that wire. So as we look forward, you're going to need that data and some of this information I'm going to share to be able to answer the 5 questions. So I'm enabling the whiteboard tools. If you guys want to use the typing tool to label, that is the 1, 2, 3, 4th box down, if you aren't familiar with that. And just label the 3 parts of the electromagnet. You do need to know that for quizzes, and I have seen that pop up in one of the questions on the test bank as well. So if anybody wants to grab whiteboard tools and label, that would be really great. It's only 3 parts. Basically, it's just identifying what we're looking at. Don't be shy. No takers? All right, yes, we have the power source, which is the battery. And for some reason, that question on the worksheet stumps a couple of people. I've had several people question me like, I don't know what a power source is. So you have to think about what's providing the energy. Okay, so we do have the power source, which is our battery. You have your nail or metal rod that's the conductor, right? It's going to conduct the electricity. You have to have metal. So let's type that one on. A nail. And then we have our wire. Pretty easy, right? So you've got to know those 3 parts. That is a definite plus. You've got to know that information. All right. So if we're looking at the picture here, we're seeing another one. This is out of the lesson as well. This is in actually the motoring lesson, kind of a reminder for you of the things that you have to have in order for an electromagnet to work. So the role of the metallic core, so that would be the nail. What's the role of that? It's important to know that the metallic core has the magnetic domains that line up in response to the magnetic field created by the wire. So if you don't have a metal core, you're not able to conduct that current to make the metal magnetic. All right. And then the next question, is the metallic core necessary to make the metallic field, or I'm sorry, the magnetic field? And we know that yes, it is. We just talked about that. All right. So pretty easy, very basic. I'm not sure why that slide is blank, so we'll go to this one. The 2 things you need to remember that you can do to make your electromagnet stronger. Does anyone know what those 2 things are? I know that is a question that you will see either on the test or the quiz. Exactly, Rylan, you got it. A bigger core, so like your nail or your screw, whatever you're using, could be bigger, or you could wrap the wire around it more times. So in the pictures that we've seen in our lesson, the coil looks like the wire's kind of thick and it's wrapped around like maybe 10 or 12 times, but you saw in the video that guy wrapped it around there like over 100 times. It just kept going because the wire was really tiny. So those are the 2 things you need to remember. It's actually the bigger power supply. So your battery power source would be bigger and more wire. Okay. All right, so here we go looking at the first 5 questions. These are the questions that just go with the electromagnet. So this is basically a test, not a test, questions on your test ability when you made your electromagnet. So if you did not do that, you can just fill in answers here because you weren't able, you could look at the video. I mean, it's just a concept of understanding how the magnet works. So how many paper clips did the wire wrapped around the nail just a few times pick up? Basically, the concept that we need to know here is would it be a big number or a little number? Right, it would be low. So if you didn't do the experiment, you could say, okay, I picked up 5. Okay, because it's got a low voltage there. It's not putting off a high magnetic field. So in question 2, which electromagnet design was most successful in picking up the most paper clips? So knowing what we know about electromagnets and how we make them stronger, what would you write here? Right. In number 2, it wouldn't necessarily be a larger nail, it's a larger battery. So a bigger battery would make it more successful. You would pick up more nails because you would have more power, more voltage, okay? Or more wires, more wraps, coils around the nail, okay? So remember, it is not the size of the nail. That could be a factor, but what we're taught in the lesson is that the voltage, the battery size basically, and the number of coils. So that is your number 2. All right, so moving to number 3. Would wrapping the wire more times around the nail make it stronger or weaker? So you guys should know this one easily. Yes, it's going to be stronger because you've got more electricity flowing there. So good job. All right, number 4. What do you think the result would be if an iron nail that was much thicker was used? So this would be kind of going back to what Ryland's saying. I think Dylan mentioned it too. It would be interesting to test that and see if the metal, which would have more domains in there as well being turned, if the magnet would be stronger. So that's just our guess, and it's saying, what do you think? Based on what we know, this is what we're thinking, that it would be a stronger magnet. So we would have to test that, but that is a good answer. And then number 5, what do you think would happen if a wooden stick was chosen as the core instead of the iron nail? So remember that those 3 parts work together. If we don't have one of those and we use wood instead, right, there would be no magnetic power created. So metal has to be a conductor of electricity, right? So the electrons can flow through the metal. Wood is not a conductor of electricity. So no, it would not be magnetic. So our magnet would not work. All right, so those are very easy, 1 through 5, right? Pretty easy. Okay, so part 2, we're looking at the motor. In this lab activity, if you look through the instructions, there are lots of steps to build that motor. So if you're trying to think, engineer mind kind of person, and you like that stuff, that kit is in there, and it's really fun to do, to get it to work. But I know a lot of us are kind of in a time crunch sometimes at the end. We don't really have time to build through and, build a little motor. So I know a lot of times students are not able to complete this portion. So I do want to share with you a video. It is a little bit long, and I don't want to, it kind of is slow to start, but it just shows you the very basic setup and build of a motor so you can get an idea of how it works. And then from there, you will be able to answer those last 3 questions. So this is funny, I found this clip. Mr. Wizard, it was a science show that was on when I was a little kid, so like 30 years ago. This was a show that you could watch, and he would do all these science experiments. So it was really cool. So it's before like Bill Nye and Steve Spangler and all of those fun people. So here's this. I'll probably end up cutting it off early because it is about a 5-minute video. So here it comes. All right, guys, I'm going to stop the video right there. You have the link if you wanted to go check out the end part of it. But basically, you're able to look very carefully and see the pieces that need to be put into place in order to create the motor. So the electromagnet is a big part of allowing the different magnets to turn off and on and allow things to move with the polarity. So that's the important part I wanted you to see. All right, so if we take a look really quickly, this is out of the lesson, and it's just talking about the parts that you need in order to create a motor. You have to have a magnet, you have to have the wire coil, and you've got to have the electric input. So you have your battery, the wires are connected, and then you've got a rotating loop. If you saw on every example that he showed something was spinning, right? And that is what's creating that mechanical energy. And you have to have a magnet. So those 3 things, 4 things, are really basically the guts of the motor. Okay? So if we go and look at the 3 questions associated with the motor, we're looking at 1, describe the components that are necessary to make a motor run, and what do they each provide? Okay, so it gives you your first one. The battery provides voltage, so you've got to have a battery. You also have to have what? Right, we have to have the wire. The wire does 2 things. To coil around the metal and to connect to the power source. Okay, so you've got to have that. Okay, what else did we need? What was in our picture just now? A magnet, yes. So the magnet changes, actually it allows the polarity. So with the magnet being like the north, the south, as it moves, it's conducting the electricity and it's causing the magnet to spin. Do you remember that part of the experiment where he was showing just the magnet spinning on the table? So that's how you get the motor, the part that actually is turning. So you could even just, conduct, well, let's see, transfers, let's do that, transfers polarity, making opposites repel. That may help you remember that is what causes the spinning. Okay, and what else did we have in the picture? Do you even remember the last part? We had the wire coils. Right, that rotating loop, that's the wire coil really. You've got to have that loop that goes around your metal piece, your metal conductor. So you have your metal, which conducts, whoops, I didn't spell that right. Okay, so that metal is important. All right. So here you've got to be able to explain how the homemade motor makes the mechanical energy. Remember, mechanical means something that's moving, how it makes the mechanical energy from electrical energy. All right, so in your own words, you're able to describe that the power source or the battery is the electrical energy, right? The wires are transmitting that electrical energy to the magnet and the wire coil, which causes the spinning motion, and the spinning motion is the mechanical energy. Okay, does that make sense? Electrical energy starts in the battery, goes through the wires, through the coil, through the magnet, through the metal, which causes the spinning motion. The spinning motion is the mechanical energy. So hopefully you're able to write that in a sentence. And then finally, the last one, so very easy, you're listing 3 appliances in your house that use a motor. So that means they're basically turning electrical energy into mechanical. So I'm sure you can think of, so if it has a motor, basically it moves. You have to think about that. Like a coffee pot just uses electrical energy. Changes things to thermal, but it doesn't have a motor in it. So not a coffee pot. Not really a toaster. A toaster doesn't, really move. But like a lawnmower, a vacuum, something like that. All right. So are there any questions on answering those 3 questions? I know we are at the top of the hour, so I want to make sure that everyone was able to get all of those answered. Yes, washing machines have motors. Your blender has a motor. You have maybe an electric mixer that has a motor. All right. So if you have questions and, oh, no worries. So that one is explaining the process of electrical energy going to mechanical energy. So you're going to have to write out